everyone, today I'm going to be doing the worked examples from exercise 6.3. It's the product rule, and I have done this video already, but unfortunately I had my microphone off, so we will do it again, and hopefully this time it will work. So it's of course from the Jacplus textbook, and here's the first example, but I'll just point out the product rule is when we have something where we've got something times something else, and we call them U and V. So in this case, well, you can see that there is an x cubed, and that's multiplied by sine 3x. So I'm going to say let u equal x cubed and let v equal sine 3x. And in this case, well, it's not really necessary to say let y equal g of x. You could just leave it as g of x if you wanted to. U dash we're going to need, which is 3x squared, and v dash we're going to need sine, where when we derive sine, remember we go up the hill first, so it's positive cos. So we've got all the constituents now that we need, and what the product rule is g dash of x equals u v dash plus v u dash. And as you know, when you add things together, 1 plus 3 equals 4 and 3 plus 1 equals 4. So it doesn't matter which way round you go. However, choose one and kind of stick to it. So let's do that. U v dash times v u dash. U v dash is going to be 3x cubed cos 3x plus v u dash. So v u dash is going to be 3x squared sine 3x. And look, there's not much value in removing a 3x squared from the brackets there to factorise it. This is probably the best way to answer this, so we'll leave it like that. Going to the next one. So here we are finding the tangent, the equation of the tangent to the curve at a point. So we know what a tangent is. A tangent is y equals mx plus c. And of course, well, we're going to need the gradient, and to do that we need a gradient function. So let's do a gradient function. This is y, so dy over dx is going to be uv dash plus vu dash, because we've got something times something else. So let's have u, so let u equal e to the 2x and v equal x plus 1 squared. And look, in order to derive v, you're probably good to expand this bracket. So it's a plus b squared, so it's x squared, a squared plus 2ab plus b squared. So the derivative of that would be 2x plus 2. It's quite easy to do like that. And then, of course, the derivative of u would be 2e to the 2x, because, of course, e is its own derivative. So let's apply the product rule. uv dash e to the 2x times 2x plus 2 plus v u dash, which is going to be 2e to the 2x and x plus 1 squared. So now that we've got that, we can find out when x equals 0. Now, in this case, you might like to remove from the brackets the e to the 2x. So I feel like I've missed something. Oh yeah, I'm going to remove the 2 from here as well, because then I can remove the whole 2e to the 2x. So actually I'll take a 2 out of the brackets. And look, I'm not going to write it again. I'll just change it to x plus 1 here. So I've removed a 2 from the brackets out of that x plus 1. That 2x plus 2 became x plus 1, and we removed the 2. So now what we see, we have a common factor of that, and that's the 2e to the 2x. So dy dx equals 2e to the 2x, and actually more in the common factor, we can take x plus 1 out as well. So what we're left with is 1 plus this. There's a squared here, so we've already taken one of them out, so we're left with x plus 1. And then dy dx equals 2e to the 2x, x plus 1, and then this will be 1 plus 1 is 2. Plus x, or x plus 2 if you like. And we're trying to find the equation of a tangent at the point where x is 0. So let's sub the 0 in, So when x equals 0, a gradient of our tangent is going to be 2e to the 2 times 0, 0 plus 1, and 2 plus 0. Let's move up here. And that's going to give us, remember, anything to the power of 0 is 1. 2 times 1 is 2, times 1 times 2 equals 4. So far we've got the equation of the tangent y equals 4x plus c. And of course we need to find c. And if I remember correctly, it's 0, 1 is our point, but I'll just double check that. Yep, 0, 1. So now to find c, as usual, we sub in a point. And 0, 1 is a point. So we've got 1 equals 4 times 0 plus c. c equals 1. Therefore, the tangent is y equals 4x plus 1. And that's the end of that. Next, we've got to use calculus, so in other words differentiation, to find the coordinates where the gradient is 0. So just to remind you from year 11, the gradient will be 0 at a turning point or a point of inflection, so a maximum or minimum. So when you're finding the maximum value of something or the minimum value of something or a turning point or point of inflection, you're going to equate the gradient to 0. So using calculus, find where the gradient is 0. Let's do that. This we can kind of just ignore. We've got our equation f of x here. Here are the two parts. So let u equal x squared and v equal e to the x. U dash will be 2x and v dash will be e to the x because e is its own derivative. So our f dash of x is going to be u v dash plus v u dash, and u v dash, there it is. So we get u v dash is x squared e to the x plus v u dash, which is 2x e to the x. So this gives us our gradient function here, and we can remove from the brackets. Here we're trying to equate where it equals 0. So I'll just put it up here, x squared e to the x plus 2x e to the x. That's the gradient function. Where's the gradient 0? We're going to remove from the brackets, or we're going to factorize it, so we can apply the null factor law. X squared, or x e to the x I should say, open brackets, we've got an x left over, x e to the x times x will give us this, plus x e to the x times 2. There we have it. So we've factorized it, and now, well, this means x times e to the x times x plus 2 can equal 0. So if any of those parts equal 0, it means the whole thing equals 0, null factor law. So x can equal 0, e to the x can equal 0, and x plus 2 can equal 0. Now, of course, this one you can't do because e to the power of nothing will equal 0. If you want to look at it another way, if we undo it, x would equal log e0, and that's outside the domain for a log. So we reject that one. And then we have x equals neg 2. So these are our two x values. And if we look back at the graph there, well, this makes sense. Here's 1, 0, 0. And then the other one, somewhere here, neg 2. And there's some value there. So actually, I shouldn't just assume it's 0. I kind of can see it is, but we'll do the maths to show it. So f of x, we're going to now sub in to find the corresponding y values. So we know that when x is negative 2 or 0, the gradient is 0. So we want to find the coordinates. So we need the y value. So we sub it into the y equation. So let's sub 0 in. Of course, this will be 0 and this will be 1. 0 times 1 is 0. So our first coordinate is 0, 0. The second coordinate, y equals neg 2 squared and e to the power of neg 2. So that's going to be 4e to the neg 2, which is 4 over e squared. So our second coordinate would be neg 2 and 4 over e squared. So these would be the coordinates where the gradient is 0. And I believe that's the end of the examples. Let's just check. Yes, it is. Hopefully we have sound this time.